Hello. Welcome, everyone. My name is Tim Stewart. I'm president at Visual Decisions, and we are here today to talk about Lean Industry 4.0. As we're going through the presentation, if you have any questions, feel free to enter them into the question and answer, and I'll try to take care of them as we go along, and we'll also leave some time at the end. So for the agenda today, we're going to cover what is Industry 4.0, how to supercharge your Lean Six Sigma tools with Industry 4.0 data, to create a data-driven Lean culture, and to use a management operating system that has data that's bottled at the source. So let's get started. First of all, Industry 4.0, industrial IoT is very big at this point. Most every company is implementing some form of Industry 4.0, looking at how they can collect additional data from the process, utilize robots in terms of with their workers. Very many different forms of Industry 4.0 that are being utilized in industry. Very heavy investment in this, and furthermore, there's a lot of ways that Industry 4.0 can create a competitive advantage. So there are a lot of different levers that can be pulled utilizing these techniques and this data to improve the process. However, the technology alone is not enough. As you know, kind of an analogy for this, I've been carrying a Fitbit around for 7 years now, and I haven't really lost any weight. And the reason for that is that I haven't changed my behaviors. And if you don't exercise more, if you don't change what you eat and so forth, it's not really going to make a difference that you have all of these sensors carrying around, and all the pretty charts and graphs and all the data that you have available to you. But it's really that behavioral change and that process change that causes the actual weight loss. It's the same thing in manufacturing. You can implement any of these different Industry 4.0 systems, but unless you actually change the process, unless you change the behaviors of the people, then you're not going to see the improvements in the results that you're really hoping for. And so at Visual Decisions, we look at path to success for Industry 4.0. And the left side is essentially the technology implementation, mapping out the vision, how to leverage your existing investments, the tools that you already have in place today, looking to fill the capability gaps with additional systems, whether it's machine learning or anything else, and then integrating across different processes and data sources to really, create the big levers for your business. But it's really that right side that we want to talk about today. Because again, you're not going to see the improvements in the performance unless you really transform the culture and the process of the organization. And to do that, you need to tie this into the tools that you already have in place with your operational excellence program to combine those so that you can leverage it to change the process, change the behaviors of the people, and really move the organization forward. Along those lines, though, manufacturing has really embraced technology and automation. As we've seen, there's huge investments that are going on, whether it's robotics, augmented reality, the industrial IoT data collection, data analysis, and so forth, machine learning applications that are predicting downtime events and so forth. But continuous improvement really hasn't. Most of the lean programs that I go and look at, most of the operational excellence people that I talk to and so forth, really still prefer the manual methods. And so, going in there and having people, write down their shift numbers on, the whiteboard. They're doing their hourly statistics and so forth, writing down, what were the different, reasons for downtime and so forth. And then somebody comes in and they type that into Excel, and then that Excel spreadsheet gets saved out to a shared drive. And if you want to look at information across different days, you have to pull up all the different Excel spreadsheets and now tie those together and so forth. And that's all waste. Lean tells us that our definition of waste is basically anything that we're doing in the business that the customer doesn't value, and the customer doesn't value any of that. And so all of those activities are by definition waste. And if we can automate those, but still get the value from those, activities, then, we've moved the business a step forward. So how can we embrace these technology and automation within the continuous improvement process itself? And that's what we really want to talk about today, is how do we transform that operational excellence program? And so part of that is looking at the lean tools themselves and really moving those forward and connecting those to the information and the data that we're getting from the process. And part of it is the lean management program itself and how we actually manage the business. So we'll talk about both of those different aspects. First of all, let's look at the lean tools. If we look at the lean toolkit, and I've picked a graphic here that just lays it out in form of DMAIC, but it really covers both lean and Six Sigma here. And there are a ton of different tools in that toolkit. Most of them are data-based, or at least use data. And very often the way that we do this is, old school. We go out there with a clipboard and a stopwatch. And, when you do a Kaizen project, you spend the first 4 weeks collecting data. Or, if you want to create a value stream map, you take a whole bunch of different people with, interaction in the process, and you put them in a conference room, you lock the door, and you have them, give you their best estimates of how long, each individual process step takes, how long it takes between process steps, and so forth. And, you create your value stream map. Well, there's a better way to do all of these different things. So if we look at the metrics themselves that we're collecting from the shop floor, very much what is collected today are just performance metrics. So I know my first pass yield, I know my defects per million and so forth. I can tell you what my warranty costs are as a percentage of revenue and so forth. And that's all great information, but it doesn't really help me improve the process. I know where I'm at, but I don't know what went wrong. And so what we need as a next step are those diagnostic metrics, the ones that tell us for this individual failure, what was the actual problem? Why did that happen, and so forth. So not just the what of the performance, but the why in terms of the reasons. So as an example of this, we implemented at a multinational bakery company. And the first step was to create that performance overview. So we created a dashboard that at a high level showed what was the lost time. And this is due to downtime and things like that. And then we also showed material waste for overages and scrap and so forth. And we can then trend that out. We can see that by line, by shift, different ways of doing that. We can dollarize it or show it in pounds or minutes. We can see day over day performance, week over week, month over month. We can tell whether we're getting better or worse. We can tell if we're winning or losing. But it still doesn't get down to that level of detail of why. And so what we did next was, for every single downtime event, for every single scrap event and so forth, we started collecting information about why. And over time, what we were able to build is this really nice Pareto of where the losses were occurring, and then what was the category of loss that was occurring at that spot, and then what was the cause for that particular downtime event, as well as additional information of who was running the process, what was the product that was running and so forth, so that we can analyze those things as well. But as we drill into this information, so all of this is interactive. And as you drill into the biggest item on the Pareto here for equipment loss, and then the next category down and so forth, what we start to see is that we can rapidly drill into this and see what's happening on a much more detailed level. And for these oven failures, what was going on is that most days there wasn't much downtime at all due to the oven. But then we had these really big spikes that were occurring. And what we found with those was that the oven shelves were flipping due to broken pins. And by finding this and by understanding the periodicity of those failures and so forth, we were able to put in a preventive maintenance program that changed out those pins on a periodic basis, and basically completely eliminated this major source of downtime. And then there were other failures that were more minor stops that were occurring 15 times a day, every single day, and we were able to implement poke yoke procedures, error proofing, so that those didn't happen, jams and so forth. And by having this information about what was going on and why the process was stopping, we were able to eliminate many of those sources of downtime, and we were able to dramatically improve the process. So that captures these first two steps in this maturity level, the performance and the diagnostic metrics. We just kind of went through that. What is the next step? So once you kind of master that, the next step is really predicting the downtime events and predicting the maintenance needs and the tooling changes and things like that. And for that, you need to collect an even finer grain of detail. And so at that top level, I just need to know information about events. I need to know when this machine stops, what was the cause for it, and so forth. But if I want to get into predictive, now what I want to do is I want to track the actual process variables as that machine is performing its duties. And so an example here is at an automotive supplier right now, we're looking at a grinding operation. And within that grinding operation, we can look at the power draw that we're seeing for the motor that's driving the grinding wheel. And as we see that power load increase in variability as well as increase in amplitude, we can start to identify when that grinding wheel needs to be changed. And the customer is spending hundreds of thousands of dollars refurbishing these grinding wheels on an annual basis. And the dilemma that is faced there is if you replace the grinding wheels too often, you spend way too much on refurbishing your grinding wheels. If you leave them on too long, then you produce bad parts. And so by utilizing the predictive analytics, we're able to really optimize when those grinding wheels come off and get refurbished, and we're able to optimize the costs on both sides of that equation. Prescriptive analytics are basically taking the next step. So with predictive, we're saying when something is going to occur and so forth. Prescriptive analytics actually then close the loop and control the process itself, so that you take that next step out of the hands of the humans running the process. And so here, what we're able to do is, for instance, in a humid environment, different powders and so forth that you're loading into a product may change behaviors, and so you can actually change the mix in the loading machine based on the environmental conditions. And we've done that in plants as well. So that's one type of tool, going through doing a root cause analysis, doing multiple whys in the process and so forth, and really leading through a diagnostic process. I've mentioned a value stream map earlier, and how that's traditionally done in a conference room and so forth. And what we find is that we have all the information. If we're connecting into the process itself, and we're collecting information about how long the process is taking on a part-by-part basis, and we're also tracking the work order number as it flows through the system and so forth, we really have most of the information that we need in terms of the material flows through the system. And so we can automatically create these value stream maps, or at least automatically keep them updated. And the advantage of that is that we not only see our best estimate in terms of our lead time ladder, but we can see the actual time that process A is taking. And we can create a full distribution of how long that process is taking. We can see the variance within there and so forth. We can see what the actual time between processes is. And furthermore, we can start to not only keep this up to date and keep this accurate, but we can start to alert based on this. So if we're expecting to take, 1 day between processes and we have seen this work order sit idle for, longer than that, we can send an alert to somebody to say that this work order needs attention. Furthermore, we can see the deviations from the process. So we can see how often this goes through a rework loop. We can see how often this goes through an alternate routing and so forth. And so our value stream map can become much more valuable because it becomes something that we can measure against, and it also becomes something that is live and evergreen. Likewise for an FMEA. So we went through the bakery example earlier where we were tracking the different failure modes in the process and how often they were occurring and so forth. Why don't we tie that into our FMEA analysis so that, as we're seeing those failure modes actually occur within the process itself, now we can tie that back into our FMEA and keep our probability of failure updated for those different failure modes. Likewise, as we see the failure modes happen on the shop floor, if we have recommended actions for each one of those different failure modes, we can actually present that to the operator live and say what they should be doing as a result of that different failure. Furthermore, we can track the effectivity of those different recommended actions to be able to say, if we had this failure mode occur and we took this remediation step, did that actually improve the process? So being able to create this in a closed loop environment, collect the information from the shop floor, from the machine itself, or from the operator, or both, and then tying that back into the analysis makes the FMEA a significantly more valuable tool. And so all of the different lean tools that are data-based can be done this way. And if we're collecting information from the process, there's absolutely no reason that the lean tools should be separated from that data collection itself. In fact, it's much easier to make the lean tools part of everybody's daily process if they're integrated in with the data as it's being collected. So that leads me into the discussion of how we create this data-driven lean culture. And a lot of talk is out there today about the new world of work and people, process, technology, how all of these things intertwine. And really, you cannot just utilize the technology to improve the process, as we talked about before. There has to be effort across all three of these different pieces of the organization in order to really make those improvements that you're hoping for within Industry 4.0 initiative. I go back to David Mann's kind of seminal book within Lean of creating a lean culture. And what he talks about are the different steps for creating that culture within your organization, looking at the management system, the principal elements of that, really focusing on standard work for leaders, visual controls on the shop floor, daily accountability process, having that checklist of things that you go through for everybody in the organization. Gemba walks so that leadership really sees and understands the process. How do you build up that leadership team over time, and then how do you implement these rapid process improvements? And every single one of these is presented in the book through those traditional manual methods. And while I love the book and I have a tremendous amount of respect for the process itself, as we just talked about, if you really embed those things into, or if you embed the data collection from the shop floor, if you embed that analysis into the processes themselves, now you have the opportunity to really drive the organization forward that much faster, to really utilize not only that lean thinking, but also that data-driven philosophy. So, some of the examples of this, I talked about the visual controls earlier, and when I'm talking with traditional lean people, this is usually the pushback that I get, is that the engagement that they are looking for from people coming in and writing their hourly results on the whiteboard and so forth as they go through the day is critical to the adoption and setting the culture and so forth. And my answer to that is that you can still engage the people with that frequency. You can still engage the people in the process itself and so forth, but you can do it at a higher level. So rather than having people just track the number of pieces and the number of the amount of downtime and so forth, if that information is already there, now you can engage them at a higher level. So it's not only tracking those little data pieces, but now what do I do with that? So a great example here is at customer Unilever. We implemented what we call TPM Tuesdays. And within the organization, what we did was every Tuesday, we actually stopped the line and we utilized the data coming from the system itself to improve the process. And we looked at, what were the top 3 failures over the past week. And we said, what is it that we can do today to improve one of those reasons for downtime? And then, if there's something that we need a larger scale project for, let's get that kicked off as well. And so these TPM Tuesdays were tremendously successful. They drove a tremendous amount of engagement and interaction, not only from the supervisors, but also from the teams themselves working on the lines, and really saw dramatic improvements in the results. So, part of what David Mann talked about in his book was creating that management operating system. And what I want to do is talk about how we can create that with data that's kind of bottled at the source. And so first of all, the data that we're collecting should align to the process itself that we want to put in place. And so if we look at the different tools around Six Sigma, TPM, TQM, lean manufacturing, a focus on OEE and so forth, all of those different things require data and data from the process. And then, the process improvement side of things as well. And so one of the things that we should focus on as we're implementing these Industry 4.0 systems is not only, we want to put in this machine learning system to, actively, predict, when that grinding wheel needs to come off. But, as we're doing that, what is the other data that we can be collecting from that system, and how can we utilize that data in all of these different processes to improve the operation? So, as we're collecting information about how that process functions and so forth with the grinding operation, we're also looking at comparing what is the performance of our better operators versus our less experienced operators, and using that as a training opportunity to say that when our best operator runs the process, here's what that profile looks like, because we have all of that detailed kind of DNA of the process itself. And then we can look at, a different operator running it and see what are the differences and, what are the training opportunities that we can work on with that less experienced operator. If we look at the lean management operating system itself, very commonly this is policy deployment. We have a traditional X matrix here where we're looking at the long-term objectives for the top level, looking at that to the annual objectives, then the short-term initiatives, and what are my critical metrics to improve and so forth. And this is great and so forth, but it's very disconnected from the process. So I still want to go through the same planning process and looking at how I'm going to align the organization across the different levels and the different functions and so forth. But now what I want to do is I want to tie this into the results that are coming in directly from the shop floor and be able to report whether I'm winning or losing at any given time. And so, typically in a lean deployment, this is done through metrics around safety, quality, delivery, cost, inventory, and manpower. And we look at those as being different at that corporate staff level versus, the plant staff all the way down, to the team leads. And looking at that strategic, operational, tactical, et cetera. And so if we're collecting the information directly from the process, it's very easy to see, how that can, give us our measurements for, the team leads, the associates on the shop floor and so forth, and even the supervisors and the team leads. But if we're collecting that information from the shop floor, we should just be, aggregating that information, passing that up along the line And we should ultimately be able to tie that into the SQDCM metrics for the corporate staff itself. And so what we've done in multiple different companies is to look at the management operating system and the metrics that they're tracking at all of the different levels, and really tie that into a complete process where, as we gather the information from the shop floor, we automatically calculate those metrics at each level of the organization and be able to present a view for every person, whether they're what are their metrics, are they winning or losing, how are they performing over time, are they consistently good, are there problem areas that they have on a weekly basis. Then also track the reasons. So as we're collecting those reasons on the shop floor, we should be able to bubble those up and be able to say, these are the things that are impeding our performance across these different metrics, and have that all tied together. Then kind of the last step here is actually dollarizing this. And so if you look at a lean accounting perspective, where you really want to focus on the direct costs of the organization, and you can look at what is my part usage, material usage, where are my people on the shop floor, how are they, what are they doing at any given time, and so forth, as well as the operational expenses of running the equipment, my utilities cost, and so forth. All of those things are tracked through Industry 4.0 if you choose to. And what we have the ability to do then is to place those within the business context, dollarize those, and provide a real-time dashboard. And so one of the really interesting conversations that we have with our customers is actually with the finance department of, right now, a lot of those indirect costs are just kind of peanut buttered across the process with best guesses and estimates. And if we can provide the finance department with these actual real-time views of what is the performance that's happening on the shop floor, you don't have to take those indirect costs and just peanut butter them across the process anymore. You can actually allocate those in a much more fine-grained and intelligent way, as well as looking at those direct costs within the system and having that dashboard for the plant manager to say, where are my variances on a real-time basis as opposed to just standard cost. So where are my actual variances on a day-to-day basis versus both what my standards are, and as well as what my averages are, what my typical performance looks like. So wanted to leave 15 minutes for questions here at the end. So we're kind of right on target there. If you have some questions, please put them into the chat, and I'll take a swing at answering them. If there are no questions, we can call it a day. And I'd be very happy if you reached out to me, Tim at visualdecisions.com, or give me a call at 630-957-8096. And let's talk about where you are with both your lean and Industry 4.0 journeys, and how we can best get those working together. I must have done a really good job because there are no questions in the chat. So I'll just give this one more minute here before calling it. All right, well, I want to thank everybody for coming this morning, and look forward to talking with you in the future. Thank you very much.